Let's jump right in. Welcome to this explainer, where we're going to pry open the ultimate toolkit, the fascinating set of methods researchers use to literally build human knowledge from the ground up.
I mean, think about it for a second. How do we actually know what we know? Before we can trust a flashy headline, a history book, or some huge medical breakthrough, we really have to ask ourselves, how is that truth constructed? Because the knowledge we rely on every single day, it didn't just magically appear out of thin air. It was methodically, painstakingly built.
And to build that truth, you need a highly precise set of tools. We call these tools research methods. Think of them as structured pathways specifically designed to investigate social, physical, and historical phenomena. They're carefully categorized based on distinct designs, analytical approaches, and very specific objectives. It's like a giant puzzle, and you need the exact right piece to make sense of it.
So here is our roadmap. Today, we're exploring 5 foundational methods: the quest for truth, testing cause and effect, observing the present and past, the epic battle of words versus numbers, and finally, choosing the right tool for the job.
All right, Section 1, testing cause and effect through the experimental method.
This method is an absolute powerhouse. It's a scientific approach built specifically to establish definitive, undeniable cause and effect relationships between variables. Here, manipulation is the name of the game. The researcher actively and deliberately changes what we call the independent variable, or IV, just to see what happens. It's literally like turning a dial on a stereo to see how it directly affects the volume.
Now, the outcome we measure, that's the dependent variable, or DV. But the absolutely crucial point here is that while we turn that dial on the IV, we strictly control all other extraneous background factors, right? We want a clean test, so we often use random assignment to totally eliminate selection bias. This ensures that the effect we're seeing in the dependent variable is truly caused by our manipulation, and not just some random coincidence.
Depending on whether you need strict lab control or natural, messy reality, researchers deploy a few different versions of this tool. A true experimental design relies heavily on random assignment and control groups. Think of your standard, highly regulated lab drug trials. But hey, sometimes randomization is completely unethical or just plain impractical. That is where a quasi-experimental design comes in. Like if you're studying the impact of a teaching method on pre-existing school classes where you can't just shuffle the kids around. And if you really need to see how things work out in the wild, you'd use a field experiment, intentionally trading some of that strict laboratory control for higher ecological validity.
Moving right along to Section 2, observing present and past with the descriptive and historical methods.
Now, these tools don't manipulate things at all. They simply observe reality exactly as it is. The descriptive method captures the current status of a population, zeroing in heavily on the who, what, when, where, and how much. But importantly, it does not attempt to answer why. You can track data at a single point in time, which we call cross-sectional, or over a long period, which is longitudinal. Researchers gather these broad baselines using surveys, questionnaires, and observational studies. They might even use correlational research to measure statistical relationships between variables. But remember, and this is key, because there's no manipulation happening, correlation here absolutely does not equal causation.
But what happens when variables can't be manipulated or recreated because, well, the events have already occurred? For that, researchers pull out the retrospective, source-driven historical method. This is all about the systematic collection, evaluation, and synthesis of past evidence. The goal? To reconstruct historical events and truly understand their influence on our present day.
But historical evidence doesn't just get accepted at face value. No way. It goes through a rigorous process called historiography. First up, source collection, gathering primary sources like eyewitness accounts and secondary sources like historian interpretations. Then comes the really critical evaluation. You have to test the physical object itself, known as external criticism. This means doing things like carbon dating the ink or analyzing its chemical age to ensure it's genuine. After that, you test the message, which is internal criticism. This checks the document's actual statements for accuracy, trustworthiness, and context. Both the physical object and its message must pass these strict tests before they ever become accepted as historical truth.
Let's dive into Section 3, words versus numbers, the qualitative and quantitative methods.
These two titans of research have very, very different philosophies. Qualitative methods seek deep, subjective meaning. They use inductive reasoning, basically generating theories directly from observing people in naturalistic settings. It's all about depth over breadth, relying on non-numerical data from smaller, purposefully chosen samples. On the flip side, quantitative methods start with existing theories and use deductive reasoning. They are highly structured and seek objective, generalizable truths. They do this by gathering hard numerical data and using standardized measurements across massive probability-based samples.
To really capture that qualitative depth, researchers use highly immersive tools to gather incredibly rich human experiences. For example, they might use phenomenology to dive deep into a single individual's lived experience around a specific event. Or they might use ethnography to completely embed themselves in a group's culture over an extended period of time. They might even use grounded theory to build an entirely new theoretical models straight from field data. And they pull all of this together through semi-structured interviews, focus groups, and really detailed participant observation.
Conversely, quantitative researchers, they demand precision. They rely heavily on mathematical techniques to spot highly replicable patterns. First, they summarize their raw information with descriptive statistics, finding the mean, the median, or the standard deviation. Then, they bring out the heavy artillery, inferential statistics. Using powerful tools like t-tests, ANOVAs, chi-square tests, and complex linear or logistic regressions, their ultimate goal is to take a small standardized sample and confidently predict the properties of a massive population. That is how they validate or refute their initial hypotheses.
And finally, Section 4, choosing the right tool. Let's do a quick methodological summary.
When you lay it all out, it really just comes down to choosing the exact right pathway for the job at hand. Do you need causal clarity? You use the experimental method. Want to gather broad baselines on a population? Go descriptive. Trying to reconstruct the past? That's the historical method for sure. If you're looking for nuanced human experience and context, choose qualitative. And if you need highly replicable, hard numbers and generalizability, quantitative is your undisputed champion. It's all about using the right tool for the right job.
So as you navigate the world's endless stream of data, statistics, and historical claims, I want you to remember this toolkit. The next time you see a compelling headline or a profound historical assertion, ask yourself, what specific tool did they use to build this, and does it actually hold up to scrutiny? Because once you understand how the truth is constructed behind the scenes, you will literally never look at the world the same way again. Thanks for joining me on this explainer, and remember to always keep questioning.